This graph shows the salaries of employees at a certain paper company in a certain town in Pennsylvania.
Michael, are you having money problems?
Monkey problems? No, I'm not having monkey problems. Why would I have monkey problems?
I know you heard me correctly.
Oh, I hate monkeys.
The salaries are in thousands of dollars, and as you can see, there is one person making way more than everybody else.
If I had money problems, would I do this? Well,
just put a bit in your pocket.
Yeah.
Now, once Michael fixes all of the monkey problems at Dunder Mifflin, he decides everyone at the company deserves a raise. And somehow he finds the money to give every single person at the company a $5,000 raise. So their salaries all increase by $5,000. Looking at the graph, here's how their salaries change. You can see on top, we have the original salaries, and on bottom, these are the salaries after the $5,000 raise. Really, the only thing that's happened here is the entire distribution has shifted up $5,000. We just took the distribution and moved it somewhere else. Let's think about how the center, spread, and shape have changed now that everyone's gotten the $5,000 raise. The center looked like it used to be around 50, maybe a little bit less. That has just shifted up to be around 55 or a little bit less. So the center has just shifted up 5,000. Now, the spread hasn't changed at all. Before, the range was 45 to 90, and now it's 50 to 95. Like, the minimum and the maximum have both moved up the same amount, so the range hasn't changed at all. And it doesn't seem like the standard deviation has changed at all either, because all the data points are still the same distance away from the mean. You know, the mean moved up with all the data points, so their distance from the mean hasn't changed. And then shape, I mean, it was very skewed right to begin with, and I think it's exactly the same now. It's still skewed right. The mean shifts according to whatever you're adding or subtracting, so either up or down, but the spread and the shape do not change. Okay, so let's say even more monkey problems are worked out and Michael finds more money to give to people. Instead of a $5,000 raise, he can give a 20% raise to everyone at the company. Now, a 20% raise is a little bit different because each person will be getting a different amount of money depending on what their starting salary was. So for example, the person that was making $90,000 is going to get a substantial raise, while the person who was making $45,000 is going to get a moderate raise. So you can see here the original is on top and the 20% raise distribution is on the bottom. Clearly the entire distribution has shifted up like before, but you will notice that it's a little more spread out. It's a little easier to see if we put all three scenarios together. So I have original, and then the $5,000 raise, and then instead the 20% raise. Once again, let's think about center, spread, and shape. Clearly the center has moved up in the 20% raise. We're not really sure how much, but it looks like it's now around 60 instead of 50. Spread is definitely bigger, but shape I think has stayed the same. It's still very skewed right. I think in order to figure out what's happened to the mean and to the standard deviation, we'll need to look at the actual numbers. So here we can see the original mean, the mean with the $5,000 raise, and the mean for the 20% raise. Same thing with standard deviations. So our hypothesis from before looks like it's correct. With the $5,000 raise, the mean just shifted up 5,000, standard deviation did not change. With the 20% raise, it looks like the original mean was multiplied by 1.2, because that's how you would calculate your new salary with a 20% raise. You would multiply by 1.2. And quick calculation, it looks like that happened to the standard deviation as well. 11.27 times 1.2, that's 13.524. So when we multiply an entire data set by a number, the mean gets multiplied by that number, and so does the standard deviation. The shape doesn't change. So just to summarize everything we just saw. It's mostly common sense. Like, I wouldn't waste brain space memorizing this. I would just kind of think through it logically. Okay, so I have a new distribution here. You'll notice that it looks very similar. The shape is exactly the same. The points are all in the same spots, but the numbers are different. So just to be clear, here's the original distribution and here's my new mystery distribution.
It's still a mystery.
Let me explain how I got this new distribution. First, I took every single data point from the original distribution and I subtracted 52, which was the original mean. Now we know that when we subtract, the entire distribution shifts down. So if the old mean was at 52 and I subtracted 52 from all the data points, the new mean is 0. 52 minus 52, that's 0. Then, once I had shifted the entire thing down, I divided all the data points by 11.27, and that was the standard deviation. Now, we know that shifting down did not change the standard deviation, but dividing by 11.27 will change the standard deviation. The original standard deviation was 11.27. When I divide that by 11.27, I get 1. Now, what is it called when you take a number, you subtract the mean, and you divide by the standard deviation? Is that a thing? Does that have a name? Maybe with a letter in it? Yeah, that's a z-score. What I did was I took the entire distribution and I converted all of those values into z-scores. If you convert all the values in a data set into z-scores, what you get is a standardized distribution. When you standardize a distribution, you're going to end up with a mean of 0 and a standard deviation of 1. The reason you might want to standardize is so you could compare two different groups. Like maybe Michael wants to compare his branch to like the Ithaca branch. If they standardized all of their salaries, they could easily compare to Michael's branch. It wouldn't make sense if these were their actual salaries. Like obviously nobody is making negative $0.5. Maybe Creed. I feel like Creed has stolen enough money from the company that he probably owes them 50 cents. Standardizing values is super important, and we're going to see why in the next video.